Good afternoon, everyone. My name is Chad Barnabe, as you now know. I've been with Elmer's for just over 6 years now. Today, I'll be presenting the Agricultural Implement Connectivity Project. I would also like to say a quick thank you to VTC and to Ron for this opportunity. So let me start with a background about Elmer's. We design and manufacture ag equipment. We have our grain carts, which are highly customizable and built to customer demand in Altona. We also build ditchers, harrows, and bale processors. This year, thanks to this project, we are introducing the Hive Mother Bin to our 2025 lineup. When I started with Elmer's, we were about 80 employees, and we have since grown to around 250 employees. We introduced our electronic technology to our product line back in 2019. Elmer's was founded in 1978, with our current CEO, Mike Friesen, taking over in 2010. We started a larger expansion in 2020 that has enabled us to grow significantly over the past 4 years. Now, for this project, our main goal was to create a link across multiple implements, eventually breaking into our other product lines. This focus was on grain carts and mother bins to coordinate operations using real-time machine data to the users. We also want to provide cloud access for our users, allowing a remote view of operations to managers or support roles such as product support. This is also the design of a new product to kick off this project, the Hive Mother Bin. Part of the intention was to use this product as a central hub and a temporary grain storage unit. Part of fitting this tech to our mother bin included making it retrofittable to other product lines, such as the grain cart. So let's talk about the intercommunication between implements, or in this case, our mother bin and our grain cart. Our first approach was to use the mother bin as an on-field hub. The appeal was going to be that we could utilize and offer cloud access in more locations than the LTE connection. Mobile units would be fitted with radios to create a mesh network. That would be the grain carts and potentially combines at some point. Ranges of these units could extend up to 1.6 kilometers, which would cover the majority of mile road fields, which is common in North America. And anything in excess of those distances, a mesh network could bridge the gap between all the units. We have Wi-Fi available on the controllers themselves, but due to the inherent low range of the Wi-Fi, we only use it for customer device interfacing. Finally, we have the Starlink unit itself. That was going to be on the mother bin that would upload all the other implements' information to the cloud, allowing that remote access to the managers and potentially remote diagnostics capabilities. We'll talk later about the results of this configuration, including the Starlink power source and radio throughputs. As we progressed, we made changes to our controller on the mother bin for functional reasons, such as real-time controls, along with a Linux-based system for higher level functions. What we found was most of the areas we were operating in had sufficient access to mobile networks. With this we decided to change over to a cloud-centric model, allowing every unit to have LTE access. We had tried a cell-based tower network in the past with another controller, but due to things like regional SIM cards, the technical proficiency needed to install those SIM cards, restrictions on purchasing SIM cards through Canadian suppliers, and the lack of functionality across multiple networks, we found it to be a major limiting factor, which is what pushed us over to the Starlink approach at first. However, when we made a change to the controller, this allowed us to move to global SIM cards and an external antenna, along with network expansions, global SIM cards, which made it easy to set up across multiple countries. We dramatically changed our perception on the LTE viability. I want to quickly go over a cost analysis of these setups, as well as to give you a rough idea of when it would be more economical and more viable to choose a specific setup over the other. The controller, in this case, was excluded from the cost because it's integrated as a primary functional controller, which was required for both our setups. When we start looking at it, the radio fixed cost was around $1,600, and the Starlink dish, depending on the type you choose, ranges from $500 to $3,000. However, our LTE antenna and cable was only approximately $50, and it also houses our Wi-Fi and GPS. Looking at monthly costs, roaming plan with Starlink, it's about $189 per unit, while our LTE cost at volume would be about $10 per gigabyte. And this is a data plan that you can top up as you go. Looking at these two scenarios, what we end up seeing is using a central hub requires you to use about 10 gigabytes of data per month and 3 or more units using that data for it to roughly start paying off at the 20-month mark. This would obviously change if you're increasing the number of units or increasing the amount of data usage, which would change the period of payoff. However, when we were operating ourselves and looking at our current case, we are well below 1 gigabyte per month, which means we wouldn't reach those payoff points. And because of our setups, we wouldn't be exceeding a ratio of 5-to-1 Starlink units because most fields won't be exceeding 3 grain carts. Economically, the LTE connection will significantly decrease initial upfront and monthly costs to our end users. That would vary if we saw a large change in our current data usage. So now let's go over and get into coverage and throughput trade-offs between both options. Data shown here is from the Government of Canada and United States government websites. With LTE, we were concerned with the throughput and coverage areas. I don't have any details on sub 1 megabit per second connections. Our current market is for the grain belts spanning southern part of Canada from Alberta over to Manitoba. In the US, starting from eastern part of Montana over to North Dakota, and then south of North Dakota down to Oklahoma. Also predominantly well-covered area of the map. We're seeing 1 megabit per second or better coverage. Cell towers also tend to perform very well in this predominantly flat terrain, with most of Canada's population also being in the first 100 kilometers of the US border. It gives us a good coverage map as well. Let's take a closer look in at our Canadian coverage. What we see in Manitoba, most of the areas with fields have faster rates of data and some level of coverage there with some level of coverage. We still have gaps in that coverage. Most of it is marshlands, parks, but there are still some fields falling on just the outsides of those edges of coverage. As we move out into the hill terrain of Saskatchewan and Alberta, we start to see a lot less coverage. A large amount of that terrain is still not farmland, but adjacent areas still fall short, specifically zones sandwiched between foothills. That's where we see a lack of coverage. This still makes up a minor amount of our current customer base who would not be able to be covered by an LTE option. The majority of our user base would benefit from the cheaper LTE option, however. Here's some field test data that we've got while we were doing our radio tests. Our partners at, and it was our partners at Mode 40 who put together these radio setups for us. So what we found is we can hit our mile road distance with our antennas. So if you look over at the lower line, it's the starting signal at minus 60 dBm, and it's dropping off below minus 105 dBm at the 1.6 kilometer mark, where our throughput also falls to nothing. We see the throughput start in the kilobits per second at about 1400, which is the equivalent to 1.4 megabits per second. And that drops down to about 0.5 megabits per second at the 1.6 kilometer mark as well. We had been expecting to hit up to 25 megabits per second, but it was never actualized in the field because we optimized our configuration to reach the 1.6 kilometer range on flat terrain. So this is viable for some smaller throughput requirements. Example are weight, GPS data, some sensor feedback, and on-load transactions would be covered. We would suspect some limitations when we remote in, especially when utilizing the Starlink to radio connection. And as that distance increases, our throughput would fall, and this is where we suspect there would be an issue. Distance can also be increased farther than we currently reached at a cost of throughput. If we had gone with the 900 megahertz band instead of the 2.4, but we avoided this due to some licensing and power concerns when we start crossing over into multiple countries. Here we have some example data produced by Mode 40 of the expected radio coverage potential to compare our flat terrains with our hills. So as you would expect, our range would be reduced in the same area we expect low LTE coverage. So as we get into the areas with low LTE coverage, we also see our radios become less effective. The radios would be more robust and able to still provide information at close distance to keep some functionality moving and then upload over Starlink. But we would have a heavier reliance on the mesh network, and you would need to be staggering your equipment in order to reach those distances. And this means that any real-time data needs would still have gaps in the process and potential dead zones. Let's talk a bit about Starlink and their throughputs. So they have numerous specified speeds listed on their website. Over to the right of this table, we have our confirmed data rates. We used a standard fixed antenna that's actuated, and we used their roaming plan. When we field tested these units with our final hardware iteration, we found that the data rates matched those set by Starlink. We'll talk shortly about where we did not meet those speeds and why. Another note about Starlink would be the reliance on the customer to purchase their own dish or accept the need to manage their device for the customer and go through a process of transferring ownership. Starlink units right now are also currently country code locked, making it difficult for us to source dishes in Australia, for example. And the monthly costs would significantly rise if you wanted to change them over to an active global roaming plan. I also want to quickly show you some coverage for the Starlink speed. The darker areas on the upper two maps are the slower upload and download speeds. In the top photos, another note is on the roaming plan, you are actually given a lower priority. This means if there is a high usage in the area, you have your throughputs throttled and it's given priority to local users. So an example of that in the bottom left-hand map might be somewhere around Edmonton, where currently the availability is low. So we had Mode 40 develop a radio and Starlink power / Ethernet unit. This unit removed the need for the Starlink router, which operates on 100 to 240 volts AC. And it's also not ruggedized, the Starlink router. So to replace the router, they needed to use a PoE injector and have a 12 volt to 48 volt DC converter. And we use this to take advantage of the tractor power source. We also needed a special crossover type Ethernet cable to match with the unique Starlink wiring. The radio unit, which includes an Ethernet interface, was also installed into the same unit. When we initially tested this unit, we found some inconsistency between some initial bench test speeds, which were around 10 megabits per second, and field testing, which showed a reduced speed down to 1 megabit per second and dropping connections. The other issue we had is we designed around the current dish available to the market at the time, which was the standard actuated dish. We did this because of availability at the time. During that same development timeline, the flat high performance dish was released. So this required a larger power demand than our current PoE injector could handle. The advantage of the flat high performance dish would be the ability to operate while in motion on the field. And that could expand the hub capabilities to our grain carts. So no longer just the mother bin, which is not mobile. We have clients though, who also don't use mother bins, and this would support those setups. This is a significant cost increase for the hardware, jumping to over $2,500 US for that dish. Starlink also released the Mini, which is a much smaller, more compact, low power option. This does not require a router, so that would eliminate the need for the PoE injector in the setup. The use of its hardwired RJ45 degrades the IP67 rating on that dish. Starlink appears to have an RJ45 available to maintain that IP67 rating, but I would be cautious there. The negative to this dish is that you also need to manually align it in the field. This would mean at each field, the customer would need to physically place it and would need to be stationary, such as the case for the mother bin. For these reasons, we ended up increasing the power capability of the PoE injector to accommodate the flat high performance dish. There are not many PoE injectors on the market operating at this power demand. For the throughput speed issue, we discovered that the DC to DC converter needed to be replaced with one that had a smaller voltage ripple and was more noise resistance. The power supply was creating noise and causing a speed negotiation issue between the PoE injector and our Starlink unit, leading to degraded performance. This change also increased the throughput to a point it matched the Starlink specifications. It is a more expensive power source, but worth it to meet the requirement. We also split out the radio and the Starlink setups in order to have a simple base radio package for every unit on the field and minimize the footprint. So I would also like to note the fast expansion in the last year by Starlink, who has released the flat high performance dish and the mini dish. The mini dish, which would be a quick way to implement a solution with some effort required by the user at each site, is a nice, easy option. Beyond that, though, Starlink has announced their 2025 release of direct-to-cell network. This would support our play to use the LTE communication-based controller, which would be compatible with their network once it becomes available, and of course, depending on their network options. Our controller will also be capable of transferring data to one another directly if needed over a dual mode capable Wi-Fi. And this would be ideal for large data sinks, but this range would obviously be limited. We also see more government contracts to expand the existing LTE network with traditional towers. So between Starlink and LTE contracts, expanding the existing LTE network, we expect to see a shrinking area where LTE would not be available. Its cost effectiveness, coverage, and ease of setup has pushed our initial release to rely on the cloud-centric model. Now, I'll talk a little bit about our cloud integration. So our software team has developed a connection to the cloud, allowing for a connection over LTE. So a major benefit is our software team can now remote in to help troubleshoot a unit in the field that has a connection. So in the video playing, this is one of our Australia units with a team member located here in Altona who was given access to the unit and is navigating the internet interface for the user. We've been able to provide from Canada to Australia throughout their harvest. Users can also now run remote updates on the machine, ensuring a more up-to-date process when new features and fixes become available. Finally, the users can have their data automatically synced to the cloud with a click of a button. This allows real-time updates as well, independent of the user in the field connecting with a mobile device. Here we see our user interface indicating the last sync. Currently, it is completed by the user, but it can be done automatically as well. The automatic sync will be dependent on a customer's desire to limit data usage or the frequency of updates that they require based on certain triggers, such as an onload. To the right, we have our web interface. That can be navigated by an off-field manager, giving access to current equipment fill levels, traceability of the grain cart to the mother bin, to the truck. Users can also generate reports from here and see summarization of their field yields. While all this new product development was done, it was also done in support of our new implement. So we are releasing the Hive mother bin in our model 2025 lineup. Domestically, we built one 5,500 bushel and an original 8,800 bushel. In Australia, we have built three 8,200 bushels and two 5,500 bushels. Two of the Australia mother bins are base models without controllers, while the rest were all built with our Pro system. This includes the controller and LTE option. We initially tested three of the mother bins with the radios and Starlink units. During this prototype season, the remote access eventually provided through LTE greatly improved our troubleshooting, our diagnostics, and of our field issues identified by customers, and helped us with a quick turnaround on our software fixes. In our 2025 model year, we are doing a limited release of the 8,200 and the 5,500 bushel capacities. They come with the Pro option for weight, GPS, movement automations, and our LTE. There is also an option for a base model. We are also working towards a limited release on our product line of the updated controllers with LTE. This will help us set a path for retrofit options and a full line conversion in the future. So that wraps it up for me. I suppose now we can move on to the question period.
Yeah, you bet. So if anybody that's online here has any questions, please feel free to use the Q&A feature within Zoom, and we'll get Chad to answer your questions. I do have a question myself, is that now that you're able to establish communications between things and you can keep track of weights and those sorts of things, what do you see in the future? Now that you've established this data link, what else will you be able to do with this in the future?
Yeah, so in the future, what we see coming is the ability to help guide the user themselves. So part of the initial process is we're seeing less skilled labor in the market and sometimes on-trade labor coming in. So if the more information we can provide, the more we can guide them to make the right decisions. So decisions like which combine should they be going to go visit, what paths they might be wanting to follow along that route. And finally, just that base knowledge of who's full, who's not, and even expanding to our other product lines for diagnostics capability. We find more and more that you're communicating with someone in the field about something very tech complicated, and they don't have that ability to maneuver throughout the app or even with that tech. And this gives us that back end access to help walk them through it.
Yeah, the very, very smart man that I know at Bueller once told me, this is about 10 years ago, he says, in the future, it's not going to be so much about the horsepower of the tractor or the amount of torque or those kinds of things. What's going to be really important was how it integrates with the farm electronic system, with other pieces of equipment, with implements and those sorts of things. And this whole idea of interconnectivity between things is kind of the gateway to that, right? Is that, and it's a gateway to autonomy too. Like if you think about it, the day may come where a bin knows that it's got enough space for what a specific combine has and can call it to come and unload and then go to a specific mother bin that has space, that knows that there's a truck coming to be able to empty it. You know, that's just the ability to use that kind of decision-making power to decide which piece of equipment goes where most effectively is exciting.
And just even the accountability and traceability of each transaction is also going to be a growing aspect of it.
Yeah. Yeah. So a couple of questions here. Dim is asking, what kind of Linux on the controller? What distribution?
Debian. So we're using ARM Linux system. So for those who are curious, you can actually go look it up. So we're using a manufacturer called Odes, and we're using their FlexG unit.
Okay. And the radio on 2.4 gigahertz, how about some interference with Wi-Fi networks?
So we didn't experience a lot of interference. The main reason right now is there's not a lot of equipment operating with Wi-Fi out in the middle of a field. So that was somewhat limited. We also have the ability to change bands on all of our, or channels, I should say, on all of our equipment. So there is the ability when we do see interference to jump over to a different channel. And that also saved us in a way, but we didn't actually see any interference coming through on our networks.
Great, great. Again, any other questions, please feel free to use the chat or the Q&A. We'll just wait a couple of seconds and see if there's anything that pops up. So what's coming in 2026?
That's a good question. I don't know if I have the authority to announce all that. So.
And if you did, you probably wouldn't anyway, right?
Yeah. So yeah. Anything I say here, I'd have to stand up to. So
yeah.
That
so these these mother bins, they look like they cannot be moved full, correct? They're just, you move them empty, you plant them on the ground, lift the suspension, plant them on the ground, and they're just basically a spot for the grain carts to go or the combines to go to unload, and kind of like a buffer for the transport trucks that are coming onto the field and unloading and moving to the on-farm bins, right?
Correct. Actually, there's a lot of popularity for them in Australia. So that's our primary market that we're exporting to. But we're trying to grow that market knowledge here in North America. And we're hoping to see an uptick here in the use of the mother bins. So part of what's kind of different about Australia than here is obviously their access to elevators is significantly lower, and their hours they're able to harvest are actually quite a bit longer and different than ours because they're not dealing with the moisture the way we are. So they can go farther into the night.
Okay, that's interesting because, you know, with here, I guess if the semi can make a quick run to the elevator or the on-farm bins and then be back in time for the next load, that kind of negates the need for a huge mother bin where, you know, you could be running the trucks 24 hours and the combines 18 hours if you had a mother bin on the property, right?
Yeah. There's also the advantage of you need less truck drivers potentially as well if you're going to use a mother bin. So if you don't have the manpower to operate 3 or 4 trucks to keep up with your field, the mother bin provides that extra buffer as well if you only have 1 or 2 guys running trucks.
That makes sense. It makes good sense. How the heck do you get these things across the pond? Like, are they modular where you can unbolt them in sections, or how do you guys do that?
Yeah, so everything is actually put into containers. So a lot of effort goes into engineering a design that can actually fit into a container and then shipped overseas, where they bolt them all back together. So as you mentioned, it's actually a bolt together frame, which is what allows us to ship them that way.
Okay, awesome. So Chris is asking, regarding cloud integration, do you have your server facility in Altona?
Actually, we're doing pretty much like everyone else, where we're using AWS.
Okay. And Ryan is asking, any experience with farms in the Corn Belt with the mother bin?
I don't actually have knowledge of that. So we did we did a little bit of, let's call it prototyping this year, and I don't have the exact data of where we all ran in the States. I do believe there was a little bit of corn ran, and I know that because I've got some data to reflect corn coming off the fields, but I can't speak directly to that experience.
Okay. Any other questions out there? We'll just leave it a minute here. All right, well, seeing none, I thank you, Chad, for the presentation and for the information. And yeah, if there's any other questions about what the VTC is doing or any of our technical mission trips or those kinds of things, please feel free to reach out to me. And again, thanks, Chad. Thanks to Elmer's for the presentation. And we'll have more technical presentations starting in January again. All right. Thanks, everybody.
Thank you, Ron.
All right. Have a great day. Thank you. Bye-bye.